welcome back to the channel. It's been a while and we are solving July 26th question today. So the question is, find a city with the smallest number of neighbors at a threshold distance. So we're given a graph, now we're given edges where it's a shirt and a destination and a weight. So our goal is to return the city that has the smallest amount of neighbor cities within the threshold. So let's say the threshold is 4. So 0 can go to 1 by the weight 3. And then 0 can also reach to within the threshold, which is 4. So 0 can reach 1 and 2. So which 0 have 2 neighboring cities. And 3 as well, 3 has 3 can go to 1 and 3 can also go to 2 within the threshold. So in this case, since 0 and 3 have 2 neighboring cities, and then we want to return 3 because the problem statement said you want to return a city which the greatest number if they have the same amount of reaching cities within the threshold. Alright, so the idea is simple right here. Basically, we just want to run dice chart and then see if the neighboring distance are all in the threshold, and then we add that to the cities. So the only problem here is it's hard for us to implement dice chart, and we have a hard time even though like understanding what that is. So I'll just dive straight to the code today. So in the beginning, I'll just declare adjacency list. And then we can start processing it and processing the edges and add things into the adjacency list. So for start and weight in edges. So this will corresponding to the start and then the end and the weight. You can say adjacency list for start, and then we append a tuple, which is n and the weight. Since this is an undirected graph, we also want to add the n so that it has a start and the weight. So it means when I can go from 0 to 1, I can also go from 1 to 0. Alright. And then we know that we need a dice chart algorithm. So for dice chart algorithm, we'll just pass in the source node where we want to find the source node and then the other thing, right? So for dice chart, we need to initialize a heap that has a tuple, which is the distance and the source node. So the distance to itself is 0, and then we put a source node into it, and then we set a visited set to keep track of what we have visited. So while heap, we want to pop things up, distance and node. So this is the distance, this is the node. So we pop thing out from the heap. Heap pop. So this is the syntax for using heap. So I always forgot during my coding challenge and kind of hard time figuring out. So you just use this thing when you want to pop, and then where you want to pop from. This is the heap that you want to pop from. So if we set not in visited, and then we just continue. If not, we added that into visited. Then for the node, we want to visit all the things that in the adjacency list. For the neighbor in adjacency list of node. And then notice that this is actually a tuple, right? Adjacency list, you add a source node, a destination node, and a weight. So I would say for the neighbor, which is the node, and then as well as the distance. Since we already have distance here, I'll just make it distance 2. And then calculate the total distance. Distance 1 plus distance 2. So we only want to add that to the heap if it's within the threshold, right? So once say if the total distance is less than or equals to the distance threshold. I forgot how to spell it. Alright. And then we add it to the heap. So heap queue dot heap push, and then put the heap that you want to push in back first, and then put what you want to put in. So we're putting a distance, and right here we're putting a distance and a node. So we can put a distance and then the neighbor. At the end, we just want the Dasher to return a number of how many neighbor you visited. So we just want to return the length of visited. But notice that we also put ourselves on the list, and then we don't care about that, so we can just -1 from here. Alright, lastly is just try to call the Dasher algorithm and return the result. So I will set result equals -1 until we found something, and then min count will be infinity. So for all the source in range n, which is from 0 up to n-1, we want to call the Dasher algorithm. So we call the Dasher and passing in source, and then it will return us a count, right? So we said if the count is less than the minimum count, we set the result equals to source, and then we set the minimum count equals to count. One thing to notice here is that we actually want to make it to be less than or equals to. So let's say 0 has 2 count, right? So it would count 2 here, and then when we go to 3, is this equals to the min count again, and then we want to update it to be result to be 3, because we want to return the largest or greatest number here. So that's a thing to notice here. And one thing to notice is what if everything is 0? Let's say 3 to 2 is weight 3, and then 1 and 2 also weight 3, but the distance threshold is 2. In this case, you will always return the greatest number if everything is also the same. So in this case, everything is 0, and then you just return the largest city. At the end, yeah, with all this talk, we just want to return the result. Let's try to run this. I think I should. Oh, count equals to. Oh, I think I misspelled something right here. Oh, yep, I misspelled this one. It should be Dasher. Alright, it's accepted. Submit this. Alright, so sorry for the delay again. I will continue to upload the video for the next few days, or for the one that I miss until July 31st. So yeah, thank you for watching. See you in the next video.